and welcome to our class. In today's class, we'll be looking at the neighborhood definition for limit of a sequence. Recall the definition of a sequence, the definition of limit of a sequence. What does it say? It says a sequence A subscript n converges to A belonging to the set of real numbers if for all epsilon greater than 0, there exists a k belonging to the set of natural numbers such that the absolute value of an minus a is less than epsilon for all n greater than or equals to k. This definition involves the neighborhood of a point. How do we now define the neighborhood of that point? To define the neighborhood of that point, we can say it as this. Let epsilon be greater than 0. Then the epsilon neighborhood of a point A is the interval a minus epsilon into a plus epsilon. Let's visualize this on the number line. Let's look at our number line. Assuming that's our number line, and that's our point A. Then epsilon radius of A is something like that. That will be the epsilon neighborhood of A. And they refer to what? Therefore, the epsilon neighborhood of A refers to what? All real numbers. All the real numbers in the radius epsilon of the number A. That tells us, therefore, that the interval a minus epsilon to a plus epsilon is the epsilon neighborhood of A. That is the epsilon neighborhood of our A. And we have said that it contains what? It is the set of all the real number x belonging to real number such that a minus epsilon will be less than x, less than a plus epsilon. The set of all real numbers x belonging to real number such that a minus epsilon is less than x, less than a plus epsilon. And if that is the case, this implies that this interval is x belonging to R such that a minus epsilon is less than x, less than a plus epsilon. Therefore, how do we now denote the neighborhood of A? The epsilon neighborhood of A is denoted as the epsilon of A. And so we can rephrase this initial definition for limit of a sequence as thus. Now, the limit of a sequence can therefore be defined as follows, using the epsilon neighborhood. How do we now define that? We now say that that's the definition here. An converges to A belonging to set of real numbers if for all epsilon greater than 0, there exists a k belonging to the set of natural numbers such that an is in the epsilon neighborhood of A for all n greater than or equal to k. Remember we said we want to bring out what? The neighborhood definition for limit of a sequence. So now instead of saying that such that the absolute value of an minus a is less than epsilon for all n greater than or equal to k, we say what? Such that an belongs to what? The epsilon neighborhood of A for all n greater than or equal to k. That is the neighborhood definition for limit of a sequence. It is very much different from the one we have been using and talking about in previous videos. If you have gained anything from this video, give it a thumbs up, share it with your other colleagues. Thank you. God bless you. I see you in the next video.